going to continue what is a single section in your textbook, but I have broken into multiple sections. We're still going to be solving quadratic equations, but we're moving on to our third technique. The first technique we used for factoring, we had to have the quadratic in the form ax squared plus bx plus c equals 0. We would factor it and use the zero factor property. Next, we did the square root property, which is a nice, easy property to use if you have, say, x plus or minus some number. Quantity squared is equal to some constant number. You took the square root of both sides, remembering to use plus or minus on this side, and solve for x. Now, factoring, although it's one of my very favorite techniques, is somewhat limited because not all polynomials are factorable. The square root property is somewhat limited because the quadratic must be in this something squared format, equals a constant. So if I could perhaps connect these two so that I could take any quadratic, whether it's factorable or not, and somehow manage to turn it into this format, then I could always solve them. The process for doing that is called completing the square. That's where we are today. Completing the square. And we're going to make a rule when we are completing the square that we want the coefficient of x squared to be a 1. In other words, we don't want to see an a value. If there is a non-1 number here, we're going to divide by it. So for completing the square, we need x squared plus some bx is equal to some c number. So it's really different than what the format we need for factoring. The coefficient of x squared needs to be a 1. This can be plus or minus whatever, x. And then the constant, we're not going to have it on the left side with those terms. We're going to have it on the opposite side. This is the format that I need for completing the square. I need to show you one other thing before we begin with this process. Let's look at some things called perfect square trinomials. We studied these when we studied factoring polynomials. These are trinomials like x squared plus 20x plus 100. That is a perfect square trinomial because if you factored it, it could be the square root of x squared, the square root of 100 is 10, sign from the middle. Do you remember we checked by multiplying and then doubled it to see if we got the middle term? So this is called a perfect square trinomial because its factors are a binomial squared. And I want you just to look at something. Look at this and look at this. So our goal is going to be to turn the left-hand side of an equation, quadratic equation, that starts out looking like this. We want to change the left-hand side so it becomes a perfect square trinomial. The left-hand side, and I'm saying left, certainly could have been the right, but one side has to have an x squared and this term, and then I'm going to figure out what this term should be. Let's look at the relationship between these, just the numbers. If you took half of this, it would be 10. and you squared it, and you would get 100. That's the relationship. Here's another one. Suppose I have x squared minus 14x plus 49. This is a perfect square trinomial. If I took half of this, I'd get negative 7. If I squared it, I'd get 49. That's the relationship between this number and this one. Its factors are the x minus 7. The minus 7 that was half of this. So that's just a little bit of information for you to think about as we move on to solving quadratics by completing the square. I have some steps. Number 1, make sure the coefficient of the x squared term is a 1. If it is not, divide all parts of the equation by the coefficient. Number 2, get all variables on one side and constants, plain numbers, on the other side. Then you're about to complete it into a square. Take half of the coefficient of the x term and square it. Add this number to both sides of the equation. Factor the resulting perfect square trinomial and use the square root property to solve for x. This might seem a little confusing right now, but once we start using it, I hope it will make perfect sense. I am going to modify something, maybe. All right. Taking the lines off because they actually weren't going to give me the right spacing. Whoops. I'm having trouble with my tools. There we go. All right, I have x. Well, things are not going right. All right, I have x squared plus 2x, that's what I need on the left, equals 63. This is the correct format for starting the problem. I'm then going to take it and write it as x squared plus 2x plus a blank equals 63 plus a blank. Now, if I can fill in this blank, complete this so that this becomes a perfect square trinomial. How do I do that? All right, I'm going to use different color ink, maybe. All right, I'm going to take the 2. I'm going to take half of it, which gives me 1. I'm going to take the 1 and square it for 1. This is the number that I'm going to send back. I'm going to add 1 to both sides. This left-hand side has become a perfect square trinomial. Guaranteed, if you follow this process, this is a perfect square trinomial. Take the square root of the first, square root of the last, sign from the middle. Also, this number always matches this number. All right, equals, and go ahead and add those. In this case, it's 64. That's a little distracting, so I'll just leave the 1. Now, I'm going to use the square root property. So I'll take the square root of the left, x plus 1 equals plus or minus the square roots of 64. So x plus 1 is equal to, can you simplify that? Yes, this is plus or minus rational 8. So x is equal to, subtracting 1 from both sides, putting it in front, negative 1 plus or minus 8. So x is equal to negative 1 plus 8, which is 7, or x is equal to negative 1 minus 8, which is negative 9. Your solution set is 7, negative 9. Doesn't matter about the order. But this is why it's called completing the square. You're figuring out what number to put here so that this is a perfect square trinomial and can be replaced with the binomial squared. This work over here will be helpful as the problems get a little more complicated. Let's look at number 2. I start with x squared minus 2x minus 2 equals 0. This is not quite right for completing the square. This constant needs to be on this side. So I'm going to add 2 to both sides, and I have x squared minus 2x equals 2. Now, x squared minus 2x plus blank equals 2 plus blank. And it's time to complete the square. I'm going to take the coefficient of x, which is negative 2. I'm going to take half of it, which gives me negative 1. Take negative 1 and square it for 1. Fill in with 1, fill in with 1. And I know that that's extremely similar to the very first problem. The left-hand side has become a perfect square trinomial. It is x, the square root of x squared. The square root of 1 is 1 again, but this time the sign of the middle is negative. Also, here was the negative 1. And it's equal to, in this problem, 3. Now I will use the square root property from the previous lesson. So x minus 1 is equal to plus or minus the square roots of 3. Add 1 to both sides, put it in front. X is equal to 1 plus or minus the square root of 3. If allowed, you can use this expression to represent the two solutions. If the plus or minus symbol is not available, then you will write it out twice as 1 plus the square root of 3, comma, 1 minus the square root of 3. And my math lab does have set notation. This problem would not have been factorable. Number 1 would have been factorable. Anytime the answers you get are rational, that means the original problem could have been set equal to 0 and factored. If the answers you get, are not rational, that means that the original problem could not have been factored. All right, let's look at number 3. I have x squared minus 7x plus 10 equals 0. And looking at that, I do believe I could factor it, and that would be the fastest way. But we want to practice with our completing the square. So I need to subtract 10 from both sides. And I have x squared minus 7x is equal to negative 10. Let's put in our blanks. X squared minus 7x plus blank is equal to negative 10 plus blank. I'm going to take this number, and I like to use a different color to do that. So I'm going to take this number, take negative 7, take half of it, don't use decimals, leave it as negative 7 over 2, because remember that 7 is over 1. Take negative 7 over 2, square it, positive 49 over 4. So I will add 49 over 4, 49 over 4. Now let me pause to say something I neglected earlier. Each one of these questions asks you to identify this number first. So it would be 49 over 4. Let me back up. In this one, it says what number should be added to both sides. In my notes, that number is 1. The solution set is the 1 plus square root of 3, comma 1 minus square root of 3. In the first problem, what I added to both sides again was 1, but my solutions were 7, comma negative 9. So I neglected to mention that the questions are asking you for what was added to both sides. I have it, but I was not calling your attention to that. So let's continue. The left-hand side has become a perfect square trinomial. And sometimes, though, when they get kind of complicated like this, students are not sure how to write this part. It's always going to be x. And then you can simply take this minus 7 over 2. That will always be the right value. So it is useful to write this down to the side. Equals, okay, I need to do a little fraction work. Going over here, fraction work. I have negative 10. I'm going to put it over 1 plus 49 over 4. I need a common denominator of 4. 1 goes into 4 4 times. 4 times negative 10 is negative 40. 4 goes into 4 1 time. 1 times 49 is 49. Now I have a common denominator of 4. I have negative 40, positive 49, which gives me 9 over 4. That's my fraction work. So this sum is 9 over 4. I can't do that in my head. I don't expect anybody to have to do that in their head, but I don't want it to be on a piece of scratch paper that's thrown away. In case you need help, I can help guide you if I can see this. All right, moving on. Now it's time to use the square root property because I have something squared equals a constant. So x minus 7 over 2 is equal to plus or minus the square roots of 9/4. Can you simplify that? Yes, the numerator's a perfect square, the denominator's a perfect square, so that becomes plus or minus 3 over 2. So x minus 7/2 is plus or minus 3 over 2. Add 7/2 to both sides, put it in front. X is equal to 7 over 2 plus or minus 3 over 2. And I can actually get my two answers. I have 7 over 2 plus 3 over 2, which is 10 over 2, or 5. There's an answer. 7 over 2 minus 3 over 2. That gives me 4 over 2, which is 2. So my second response is to give the solution set 5, 2. All right. Let's look at number 4. Solve the quadratic by completing the square. I'm going to put in the number that I add to both sides, follow the process, and then get my answers. All right. I have x squared plus 11x minus 9 equals 0. According to the steps, the coefficient of x squared is already 1, but the constant needs to go to the right-hand side. So I have x squared plus 11x is equal to, it will be positive 9 over here. Let's put our blanks. X squared plus 11x plus blank is equal to 9 plus blank. It's time to complete the square to fill in the blank. Take this number, 11, and it's positive 11, multiply it by half. It's not even, so I'll just write it as 11 over 2. Do not write it as 5.5. Do not write it as 5.5. Take 11 over 2 and square it. Square the top for 121. Square the bottom for 4. So it is 121 over 4, 121 over 4. And that's the number I put in here. Back to my black ink. This is now a perfect square trinomial. It's x, and I keep mentioning what you need is there. It's a positive even, so positive 11 over 2. You could take the square root from here, the square root from here, the sign from the middle, or you just write down x and grab that number is equal to, I believe I have some fraction work. I have 9 over 1 plus 121 over 4. Common denominator of 4. 1 goes into 4 4 times, and 4 times 9 is 36. No change here. So I have 36 plus 121, which gives me 157 over 4. All right, I'm going to put this over here, going to use the square root property. Let me get a little more workspace if I can do this. Sometimes that catches and sometimes it doesn't. All right. Using the square root property, I get x plus 11 over 2 is equal to plus or minus the square root of the fraction 157 over 4. And I always ask, can I simplify that? Now you cannot simplify the square root of 157. You can work with it. It is divisible by 3. And so you can play with it, but there aren't any perfect square factors. So I'll leave it in the radical, but I can simplify the square root of 4. It's no longer under a radical. It is rational 2. So now I have x plus 11 over 2 is equal to this fraction. It would be very unusual if these were not the same denominator. It's very common for them to be. So I need to subtract 11 over 2 from both sides, put it there. X is equal to negative 11 over 2 plus or minus the square root of 157 over 2. Because those have the same denominator, I will write it as negative 11 plus or minus the square root of 157 all over 2. If my math lab requires you to separate it into two answers, then it will be negative 11 plus the square root of 157 over 2. Make sure you use your tab or your arrow keys to get out of the expression, comma, negative 11 minus the square root of 157 all over 2. You can see that these problems are rather long and tedious, but they have tremendous value because you can solve any quadratic equation by using this method. Let's look at number 5. Make this larger. Well, this one actually, number 5, looks rather familiar. I have x squared minus 2x equals 1. It's already in the appropriate format. So I need x squared minus 2x, let's put in the blank, equals 1 plus the blank. This is my red pen. Take the coefficient of x, which is negative 2, take half of that, which is negative 1, square negative 1 for 1. The number that you add to both sides is 1. Number 5 does not ask you to fill in what did you add to both sides. So if it asks, fill it in. If it doesn't, you skip that step. You still do the step, you just don't have to report it. The left side is a perfect square trinomial. It is x, and remember, you can just grab that number, minus 1, quantity squared, is equal to, in this case, I get a sum of 2. Square root property. X minus 1 is equal to plus or minus the square root of 2. Add 1 to both sides, and I'm sorry I didn't say anything, but you cannot simplify that radical. So add 1, x is equal to 1 plus or minus the square root of 2. If it's required that you write it out without this symbol, then it is 1 plus the square root of 2, comma, 1 minus the square root of 2. This holds two answers in it because of the plus or minus symbol. Let's look at number 6. We have x squared plus 8x plus 2 is equal to 0. Well, this is a 1, that's nice, but this is on the wrong side. So I'll rewrite it as x squared plus 8x is equal to negative 2, as I subtracted to get it to the other side. Let's add our blanks. X squared plus 8x plus blank is equal to negative 2 plus blank. Grabbing my red pen, take the coefficient of x, 8, take half of it for 4, square that 4 for 16. I need to add a 16 here and a 16 here. The left side has a perfect square trinomial, which is x, and here's my number, plus 4. On the right-hand side, negative 2 and positive 16 is 14. Using the square root property, I have x plus 4 is equal to plus or minus the square roots of 14. That cannot be simplified. So all I have to do now is subtract 4 from both sides, put it in front. X is equal to negative 4 plus or minus the square roots of 14. Once again, if you need to separate it, that's negative 4 plus the square root of 14, comma, negative 4 minus the square root of 14. Anytime you get numbers like this, that are answers like this, that are irrational, that means that factoring would not have worked. Even if you had been given permission to do factoring, it would not have worked. So it's good to have an alternate. Let's look at number 7. Still supposed to solve by completing the square. I have x squared plus 5x minus 8 equals 0. This is a 1, but this is on the wrong side. So x squared plus 5x equals 8. Put our blanks. X squared plus 5x plus blank equals 8 plus blank. Well, you've probably figured out by now that the problems are a little bit unpleasant when this coefficient is an odd number. So I take the 5 and I take half of it, so that 5's over 1, that gives me 5 over 2. Don't give me a mixed number, don't give me a decimal. Take 5 over 2, square it, which means square the top for 25, square the bottom for 4. So that's 25 over 4. 25 over 4. This left side is now a perfect square trinomial, but it's not very recognizable, honestly. How do you find its factors? Always x, and then here's the number. And it's a positive, so it's plus 5 over 2 equals. Well, I think I'm going to have to come over here and do my fraction work. I have 8 over 1 plus 25 over 4. Keep my 4. 1 goes into 4 4 times. 4 times 8 is 32. No change over here. So I'm going to add those for 57 over 4. That was my fraction work. 57 over 4. All right, now I use the square root property. So I have x plus 5 over 2 is equal to plus or minus the square root of the fraction 57 over 4. I need to simplify. 57 does not have a perfect square factor in it, so it stays plus or minus the square root of 57, but hopefully you can see that I shrunk the radical because it is over, and I can simplify the bottom, rational 2. So I have x plus 5 over 2 is equal to this fraction on the right. Subtract 5 over 2, subtract 5 over 2, I get x is equal to negative 5 over 2 plus or minus the square root of 57 over 2. Because those have the same denominator, let's combine them. Over 2, negative 5 plus or minus the square root of 57. Once again, if it needs to be separated, it's negative 5 plus the square root of 57 all over 2 with a comma, negative 5 minus the square root of 57 over 2. Now, one thing that I want to take a minute, there's not a homework problem like this because I just wanted you practicing the process. Right here, when it's time to use the square root property, where you're taking the square root, if this number is a negative, which means you have a negative under the radical, you would get complex answers, and they would be conjugates. So if you go back to any one of these problems, if this number turns out to be negative, then when you take the square root, you will get an I in the problem. Okay? So we don't have one of those. We're not required to do one of those, but I did want to mention it.